Okay, I think we're ready to start. Hope you enjoyed your lunch, and we're now ready to talk about the fun stuff, multi-protocol, and how we handle it in VAST. It is. So we will describe the problem where you have end users and applications trying to access the same data set from NFS, either V3, V4, SMB, and S3. And then we will spend a few minutes talking about traditional solutions and limitations, where when you try to translate between metaphors, something gets lost. And it gets even more complicated when you try to translate between one security model to another security model. And remember that we have more than one or two security models, and they are full with details. And we will then describe the VAST approach of solving that by having an abstraction layer where you don't have NFS ACLs or SMB ACLs, and you have unified access control, which I will later elaborate on. And we also want to take the best from each protocol. For example, with S3, we have a bucket policy. So why limit it only to S3? And then we will also mention the unified catalog that allows you to search and run queries and get files and objects, no matter which protocol created them. And you also want to have one auditing system where you can see all activity on your system, no matter which protocol created it. So it is a jungle where users and applications create data, for example, NFS or S3. For example, you can think of a microscope, which is an NFS client, creating data. And then you have the end users, where the end users connect from the Windows client or SMB client or Mac client over SMB. And they want to access the same data. And there are also Linux users, and they mount from NFS v3 or v4, and they want to access the same data. On top of that, you have backup applications. Some of them use S3, and again, they need to access the same data set. So usually, data gets siloed. You have a file server that serves NFS and SMB, and an object server. But then you need to compromise. You may need to move or copy data between servers. And with AI pipelines that need to consume data from file storage and object store, this is not ideal. So let's talk about file and objects and why they are different. And having said that, we will need to somehow build the bridge between file and object. So with file, you have a hierarchy of directories and files. And a directory will usually contain a limited number of files. While a bucket is completely different. A bucket is a standalone container that where you can store objects in a flat structure. You don't have directories with S3, although an object name may contain delimiters, but still it is not a directory. And you need to somehow map between file and directories and objects. And with file, usually you manage access with ACLs. S3 does have ACLs, and we will talk about it later, but it also have more modern ways to manage permissions with bucket and identity policies that you don't have with file. Another difference is that objects are immutable, while with files you can create a file, append data, override data, truncate. And last but not least, with object you have extended metadata, which some file systems support, but not all of them. And it also has some advanced and cool features like packet notification, lifecycle rules, etc. So let's talk about traditional solutions and why we think this is not good enough. So you want to have a storage system where you support object and file. So you can have, you can put object on top of file, but then you're limited because with object you want to support millions of objects, and file systems don't always support that. And then what would you do with extended metadata? And what would you do with bucket versioning? It's not natively supported with file system. So another approach would be to implement file on top of object. But this has its own set of problems because what would you do when you want to edit a file? So let's think of another solution. You can have a single storage system where you can allocate space for either a file or object. But then we end up with the same problem because we don't have real multi-protocol support. You cannot access this, or you cannot easily access the same data set from all protocols. And if you can, it has some severe limitations. And so far we didn't say anything about permissions. So permissions could be challenging. So you could manage permission with POSIX modebits. Some admins like that. It's simplistic, while other admins want to manage permissions with Windows ACLs, where you have inheritance, and you can put deny aces that you don't have with POSIX. But then this creates complications because I can create a file from SMB with a long ACL with, I don't know, 200 entries. And when a Linux client comes in and gets the ACL, it will only get the modebits, and it is unaware of the long ACL. And if it runs chmod, then that ACL will go away. And I mentioned that before, file systems don't support advanced permission management solutions like buckets and identity policies. So we believe that you need a different approach to handle this. Instead of translating ACLs and user and group IDs between protocols, you need to have an abstraction layer where you have permissions and user IDs, which are protocol independent. You don't store NFS or SMB ACLs, you don't store UIDs, you don't store GIDs, you don't store SIDs. Instead, you have a protocol-agnostic layer, and under that layer, you can do everything without thinking about the protocol above that. So you can have data reduction between files and objects. Why not? You can create snapshots, replication, etc. And then you want to manage that data. So with NFS, you have an export, which is a logical object that points to a directory in the file system. SMB has SMB shares that serves more or less the same purpose. S3 buckets are different because a bucket is a standalone container. You don't have nested buckets. And from the S3 client perspective, there's nothing above the bucket, right? So instead of having, in VAST, we don't have export, shares, buckets. Instead, we have a view. So a view is a superset of all those objects, and the view can be an NFX export, or an SMB share, or an S3 bucket, or any combination of those. It's up to the admin to decide. And now that we have a view, you can put some advanced features on top of that. You can attach a quota configuration to a view. You can create a quality of service configuration. You can create a snap on the view or replicate it. So I mentioned vast permissions, and let's dive into that. So when I create a file, let's say from SMB, I want to set an SMB ACL. And internally, we will translate it into vast permissions. So vast permissions, think of a superset of NFS v3, v4, SMB, and S3 permissions. So this is the concept behind vast permissions. So we translate, in this case, the SMB permissions into vast permissions. It's a one-to-one mapping. And the ACL also comes with SIDs, user SIDs and group SIDs, which we internally translate into what we call vast IDs. Because internally, you don't care if it's a UID or a user SID, if it's a group SID or a GID or an S3 access key. And this simplifies things. Now, your client may want to get the ACL if you run get-utter from NFS, for example, in which case we need to translate the vast ACLs and the vast IDs to the native protocol representation. So in the case where you created a long SMB ACL and you want to display it in NFS semantics, we have a limitation dictated by the protocol. So we will display only part of the ACL. But don't get confused. When we run access check, we will take the whole ACL into account. And by the way, this means that, for example, you could create a file with an ACL from SMB, and you can put deny aces on that file. And when you access that file from NFS, we will take those deny aces into account. So this is a cool feature and allows you better access control, even when you use protocols like NFS v3. And if you examine a file internally on VAST, you cannot tell if that file was created from NFS, SMB, or S3 in a good way, because this makes the life of the developer easier, because we have one access check logic for all protocols, which means that no matter which protocol you're using to access your data, you will get the same access check behavior, either allow or deny, but you get the same behavior. So there are many ways to control permissions. You can control permissions with POSIX modbits, with NFS v4 ACLs, SMB, and with S3 you have ACLs and also policies. And usually you want to use one of them in order to set permissions. Now, if you want, for example, if you want to manage permissions for all protocol with NFS modbits, that's okay. You will create files from NFS and you can chmod them. But if you create a file from SMB, then you need to define default modbits for those files. And we will use those default modbits when you create a file from SMB or S3 object. But if you try to set the ACL from SMB, then this operation will fail. And usually this is what the sysadmin wants. Or if you prefer SMB Windows ACLs, then you can use the SMB flavor. And then you have inheritance, you have deny aces, and if you create a file from a non-SMB protocol, let's say NFS, then that file will get the inherited ACL. And you can also, some customers, not so many, but some customers say, I know how to manage my permissions. I want to manage permissions from all protocols. And this is what we call a mixed flavor, where you can override permissions from any protocol. And we attach that security flavor to the view object, which I described earlier. And it means that this method of managing access and permission applies to all protocols. Okay, let's spend a few minutes talking about how we can take the best from each protocol and apply it to all protocols. Because remember, underneath we have vast objects, so we can apply features from a specific protocol also on other protocols. So S3 policies is a more modern way to manage permissions. So instead of having an ACL, you have a JSON configuration with a set of rules, where each rule applies to a bucket or maybe a prefix under that bucket. It defines if it's an allow or deny statement, and you select which S3 actions you want to include in that statement, like put object, get object ACL, etc. And you can also have conditions like only if the source IP is this and that. And this applies to all objects under the bucket or under the bucket prefix. And it means that with this, you don't need, if something changes, you don't need to recursively fix permissions. And this is a problem that is annoying for many customers. So they like this approach. And now that you have this JSON configuration, you can attach it to users and groups. And so this is an identity policy. There's also a concept of a bucket policy where you have a very similar JSON configuration, but it applies to a single bucket. Identity policy, you can put statements for multiple buckets. A bucket policy applies to a single bucket, and for each statement, you also need to state which user or group. And now that we have identity and bucket policies for S3, why not use them for other protocols? I can use it for my NFS files or SMB. All I need to do is create a mapping between NFS and SMB RPCs to S3 action types. And this is not very difficult. Like you can map NFS read to S3 get object action type. And now you can forget about your ACLs. You can manage everything from an identity or a bucket policy. And we have many customers that are happy with usage of identity and bucket policies for NFS and SMB. Another feature is lifecycle rules. So this is yet another S3 feature that you configure at the bucket level. And you can delete objects in the background on the server side. So with a lifecycle configuration, you define a set of rules that each has a prefix under the bucket, so that you can delete objects under that prefix if they are, let's say, 5 days old and are larger than 10 megabytes. And so remember, again, we don't have S3 objects stored on VAST. So it would have been more difficult for us to limit this feature only to S3, because we don't know if an object is an S3 object or is it a file. So with lifecycle rules on VAST, you can also delete NFS and SMB files. And with the addition of support for files in lifecycle rules, we can also extend the lifecycle configuration, because originally lifecycle configuration relies on the object creation time, because S3 objects are immutable. But with NFS and SMB, you can also make decisions based on M time or A time. And this is very useful for some of our customers. Another feature is bucket notifications. So it's yet another S3 feature that you configure at the bucket level. And you define for a specific prefix and a specific S3 operation like put object, delete object. And when you put an object, this will trigger a lambda function that can do whatever you want. And this is super useful for AI pipelines that can ingest data when such event happens. And so this is an S3 feature, but we don't want to limit it to S3 because for AI pipelines, you also want to rely on NFS files and SMB files. And again, you can map the S3 operations to NFS and SMB operations. And this is another very useful feature. So now that you have a storage system that support all protocols on the same data set, the next thing that you would want is to have a unified catalog because you want to be able to search your files. So you can create queries to get all files that have 777 modbits, or all files that belong to a UAD or a specific SID that were created or modified in a specific time frame. And let's say that you want to somehow, you have NFS files, and you want to somehow categorize those files, and later you want to be able to search them with the catalog. So you can create your files from NFS, and then you can, NFS is limited, right? And then you can use S3, again, on the same data set, access those files and put S3 tags on those NFS files. And then you can use the catalog to search for files that have specific S3 tags. So this is a true advantage of real multi-protocol support on the same data set. And of course, you can use the catalog. It is a table, so you can join it with other table and run more advanced queries. So remember that we spoke about traditional solutions where you don't have real multi-protocol support, and you have object on top of file or file on top of object, and then you end up with two audit systems. So if you want to understand what happens on your system, you need to search in two audit systems, each with its own structure, and this may be painful. So with this unified solution, you have a single audit system where you have entries that represent NFS, SMB, and S3 traffic, and you can search the auditing system. You can look for a specific protocol if you want. You can search a specific time frame, etc. So we're almost done. So let's try to summarize. So traditional solutions are not good enough because something gets lost, and I didn't say that, but it's more complicated to manage a system which is actually two systems, or manage two separate storage systems. And what you need is a true unification where you have an abstraction layer that is protocol agnostic, and you want to have one control object to manage your data. This is the vast view. And this makes administration easier and flexible. And then you want to have a unified catalog, unified audit system. That's all. If you have any questions, yeah.
How NFS client can access version?
Okay, so the question was how an NFS client can access versioned objects. So this is a question that we got from 2 or 3 customers, but they don't have a real use case for a multi-protocol for file and in general, also SMB, and versioned object. You could think of a way of doing that, like when you access from NFS, you can access the current version, but if you want to access in read-write mode, this is more complicated because you may need to create a new version whenever you write from NFS. We try to listen to our customers and understand what they really need. Currently, there's no real demand for this feature. Yeah.
So if I understand right, so I'm trying to do the packaging life of the whole thing in the, so the NFS client and AI server, NFS client comes to the C node, which is running NFS server. So you terminate NFS server session at the C node, and you go down with an element store to your NVMe storage, and you do all your database below it, and you create all those metadata where it is all that in the D node somewhere, and also in the C node. So that's the workflow which I'm thinking. Is that correct up to this point?
Yes. So any protocol's client comes into the VAS server. The C node, the VAS C node is where we run our servers. Externally, we have an NFS server and S3 server and SMB server, but we terminate that, and under that layer we have a unified element store which is protocol agnostic.
Yes.
And then it goes down all the way to the D node.
And then the first question is, then the metadata information is no separate server, it is built into every C node and a D node, is that correct?
So each file has its own metadata. We have flexible metadata implementation that allows you to, for example, with S3, you want S3 tags. With NFS v4, you can have extended attributes. You can have, I don't know, symbolic links. All of this is metadata that you can store on a file handle.
At the C node?
So share something about share base.
Is it a separate server?
So we every C node is able to access to access the flash and NVRAM across the entire cluster.
Whole namespace.
Yes. So when you try to access a file from CNode 1, we don't need to think, hey, this information is stored on CNode 3 and we need to forward the request to CNode 3. CNode 1 can do everything.
So, the last question is that the object store, the file store, the SMB, whatever different thing, you have to indigest all that into the D node and then you start from there, that point on, right? I mean, you have to bring in the cloud, if it's sitting on Amazon, you bring in all the object store to the VAST D node, and that's how you start your process, the whole thing.
I'm not sure I understand the question.
I mean, you don't connect CNode directly to the Amazon, to the cloud and all that.
We don't need anything from Amazon. When I say S3, I mean VAST S3. So,
but if the data is already sitting on Amazon, how do you bring that into the VAST? So you have to indigest in there.
So you can, we have migration tools. I think we just had a press release about that, that allow you to copy data from.
Different things. Okay.
Yes.
Makes sense.
Yeah.
I'm interested in the metadata architecture. For example, object protocol require object to be stored in a relaxing protocol order, and SMB require case-insensitive lookup. And what is how do we store this metadata in your database? And is that, do we compromise or sacrifice any protocol semantics in order to achieve multi-protocol unification?
So I'll try to repeat the question. So some protocols are case sensitive. Some protocols use different types of ordering. How do we handle that? And do we need to compromise? So I can think of one simple example, which is related to access check. So with NFS, when you go over an ACL and you try to find a match, as soon as you find the match, you need to stop, even if that match will deny access. With S3, when you go over an ACL, you will try to find a matching ACE that will grant you permission. So you have a contradiction between those two approaches, and what would you do? So in NFS flavor, in NFS security flavor, we go with the NFS approach. With S3 flavor, we go with the S3 approach. We don't compromise and we don't lose any metadata. Yeah.
Similar to the question, so how is the directory hierarchy looks from S3 perspective and then the SMB NFS perspective? I know
The file hierarchy?
yeah, file hierarchy, and probably if you want to, maybe that's the first question. And if both are similar, I assume that there are some restrictions on the bucket length that you have on the S3 side, or you want to make it work for deeper directory structures for SMB and NFS.
So the question was about the file hierarchy and how we actually map between file and an object. So with object, you don't have directories, but you do have delimiters. So if I create an S3 object called A/B, then you can think of A as a directory, although it isn't. And then you can, if you come in from NFS, then we will treat A as a directory. And now you can think, you can say, what would you do with, will you set an ACL for the A directory. And then it depends on the security flavor that you are using. If you're using the NFS security flavor, for example, then we will set a default ACL for the A directory. And if you configure it properly, then your NFS client will be able to access the data. The length of what? Go ahead.
Really, when you're looking at this, I mean, there's going to be the difference when you look at how we set things up. We've effectively taken the permissioning model, the permissioning views, and separated that from the protocols. Now, with the permissioning model, that also includes certain rules about how we handle things like, file names and directory names and links and what kind of characters you can use. So those ultimately all become options as to whether you want to support it. So in the case of like a multi-protocol situation where I want to use, let's say, an SMB permissioning model, but I want to access data over NFS. Well, all those questions come. You said you were talking about, how do I handle uppercase or lowercase and things there? How do I handle certain characters that are allowed or not allowed? Well, those become choices for that permissioning model that you want to use. Do I want to support all of these options? In which case, I may be able to create. Do I want to limit that so that any file or any object that I create is going to be visible across all of the protocols? I mean, if we're going to stick with the common rule set that says, okay, I'm only going to allow files that have these characters, I know that's valid for SMB, that's valid for NFS, that's valid for S3. Same thing with things like, this length of the path length, or certain delimiters in files. I mean, things like NFS or S3, it's perfectly valid to have double slashes in an object, but that doesn't make any sense in NFS. So that becomes a decision that the administrator would make to say, is this going to be something I'm going to allow or not allow? The choice of, do we want, if we allow administrators to create those kind of objects on one protocol there, then you may have to accept the fact that that object is not going to be visible across another one. Because there's no way of rubbing it. That becomes an administrative choice.
So there's no namespace unification across the protocols?
Well, there is namespace unification across protocols. Really, it's a do you want to do name mangling when it comes to do that map. So for our implementation, which we could very well do name mangling, we don't. We choose not to. Because then it's a question of which object am I actually really accessing. So, if you make the choice, the administrator makes the choice, and that can be turned around or off at any time. So, but the point here is that we want to be flexible with this, because any data that's coming in, we want to be able to support the data that's coming in from NFS originally, or data that's been migrated from SMB or from S3, and still provide the same access with the same rules, regardless of however that data is being used, whatever protocol is being used to access that. But you have to do that by separating out the permission model used from the protocols.
Yes.
I think first of all, this is pretty cool stuff.
Thank you.
And I think I don't think there's a way to get it 100% right. And I like that you said, we try to, for our customers, and try to map their use case onto the subset that we support. And people have tried to find holes, and I can think of many more get object during depends in NFS and locking and directory names. Let me reverse the question. Was there one thing that customers asked for that you couldn't give them, or that you had to make a certain trade-off in two categories of them?
So the question was, are there features that we couldn't support? I think that S3 versioning and multi-protocol is a good example. I mean, everything is doable, and we strongly believe in that, and we do everything to satisfy our customers. But sometimes customers are asking about features which they don't really need. As far as I know, nobody really needs versioning plus NFS. But if someone insists that we will do that, it is not ideal because writing from NFS into a versioned bucket is challenging and you need to think about it, but I think it's a problem we can solve. Yes. So the question was, are we thinking about supporting other object protocols like Azure Blob and GCP? So I joined Vast exactly 8 years ago, and they told me, you need to come up with an S3 solution. And then I asked, but what about, I know that Azure has something equivalent, and the answer that I got, so first they told me, don't ask questions. We need S3 right away. And the real answer was that customers care about S3. If you run in Azure, you need to use the Azure Blob storage. But 100% of our customers that need object store need S3 support. Yes?
So I'm interested in your handling of ACLs. You said you have a superset ACL that you actually store and map to whatever your protocol request. How do you handle the case that there's many cases where, you mentioned one, the actual evaluation and modification semantics just are in conflict? For example, it's shown is coming in from pure POSIX or NFS is difficult to map to SMB ACLs. Or, yeah, there's many cases where this is just in conflict. How do you handle these if you get an operation on protocol A to present them in protocol B?
So I don't remember the mapping by heart. There were some cases where we needed to think about how we want to map this specific permission from protocol A to VAST permission and then to protocol B. One example that I can think of is extended attributes in, they tell me that I have 2 minutes left. Permissions for extended attributes in SMB are not exactly the same like permissions for extended attributes in NFS v4, but we found a solution for that. Again, I don't remember the exact mapping.
So are you willing to share it with this? Because in my world, this would be the holy grail to have some standard for interoperable ACLs. And I'm sitting in this talk.
Yeah.
On this.
So I don't remember if we.
So when it comes down to it, so when you set up what we refer to as a security flavor, in terms of the permission model that you want to use on this data set, there are rules around how complex or whether you have heritage data, whether you use modebits, you want to use identity policies, but there are also rules around which protocols have you dealing with change policies. Because when you do, if I do a command on NFS v3, what am I going to go through and modify? What is the intent of the user? Do they just want to modify owner and group and everyone? Do they actually want to erase all of them? There's no way to put that, to express that appropriately. So if we're using SNB ACLs, we, in the case of NFS, we silently fail that, more because that would, if we threw an error on it, it'd break a bunch of scripts and behavior. But we will prevent those kind of modifications from happening. Just because there's no way to derive what the user's intent is, just based on the limited semantics that NFS has. For that, or even with from SNB, if you want to, SNB is going to expect things like a nerd for directives, a bunch of things there. same granularity. So you have to block certain things. And the same thing with expressing it. If I look at directory permissions over NFS on something that's controlled by S3, that's where the access is controlled by an S3 policy, I may look at it and just see that there's a bucket owner and that's it, because the notion on what group I'm part of, groups are, in some cases don't really even exist when it comes to that. There's no way to represent them. So we try our best to display things if there is a mapping for one way to the other, easy mapping, like I know that this, my user, here has a Unix UID number and a Windows SID. Okay, I can express that user on both sides. That's easy. But if there isn't, then there has to be counted. It shows up as NFS nobody, it shows up as a raw SID or maybe a UID. So there's always counted. These are always clearly defined as to what happens.
We are out of time. So I just wanted to say we made a lot of progress, and we're working on many new cool features around multi-protocol and protocols in general. If you have questions later, feel free to approach me. I'll be happy to answer. And thank you.